Hey everybody, this is Mr. Ainsworth, and we're going to get into Chapter 1 review here in Financial Algebra. So let's go right through it here. Make sure you have this printed off already. If not, press pause and obviously print it off. It would make it a whole lot easier, okay? And in this first problem here, I'm going to demonstrate, not with the TID4, although you could use it right here. I'm going to be illustrating how to do it with Desmos because Desmos is available to everyone. All right, so let's get Desmos going here. So open up your Chrome browser or any browser you want. Enter in desmos.com like you see up here at the very top. And let's enter in your data. Okay, so let's put it in the form of a table. So go ahead and hit the plus sign, hit table, and let's go to town. Okay, so let's enter in with your keyboard here 24, 53, 24, 43, 56, 31. Boom. Okay. Now, after that point, we want to calculate a few things. So what we're going to do is we're going to calculate the mean first. And the mean is another word for average. Okay. So we're going to go over here to functions. We're going to go to stats right here. Okay. It might show you a trick first. So go to the stat menu right here. And guess what? Mean is right there. But you have to tell the Desmos here what you want to take the mean of, and guess what? The values that you put in are list 1, which has a title of x1. So what you want to do is type in x1. So hit the keyboard x and then 1, and then hit the enter button. Boom, you got a mean of 38.5. All right, so if you added them up and divided by 6, because there's 6 different values, you would get 38.5. All right, so the mean, let's just go ahead and record our values. Ooh, what happened there? So the mean, x bar, is equal to 38.5. Okay, let me write that a little bit better. So 38.5, that's the average. The average is the mean. Okay, so if you sum them up, okay, this is the sum divided by 6. All right, 1, 2, 3, 4, 5, 6. There are 6 values. Okay, you would get the mean. All right, but Desmos does it for you, so might as well do the calculating. Now, when you want to get the median, all right, you have to list from low to high. All right, low to high first, or high to low, it doesn't matter. All right, and the low value is 24. Oops, sorry about that. It's getting a little crazy here at night. So there are two 24s. And then we have 31 and then 43. So 31, 43, and then 53 and 56. So 53, 56, and you pick the one in the middle. Now the one in the middle, let me see, there's 2 middle values, right? Because this is even. So n equals 6. There's 6 values. So here n equals 6. And because of that, there's 2 middle values. So when you get the median here, you average. Okay, if you want to do this by hand. So the median is the average of these two. So 31 plus 43 divided by 2. There's your median. That's 74 divided by 2. So the median should be 37. So when we go back to Desmos, okay, we're going to go to functions. Oops, sorry. Okay, pick median. I got to find it. There we go. And then, of course, you got to type in x1. So that's really hard to do. Hit the enter button. Boom. 37. And notice that I said earlier that the mean is 37 because it's the middle number. Okay, the median is the middle. So let's put that down. So the middle number in the middle, if you have 2 of them, is right in the middle. And you find that by averaging. Okay. So the median here is 37. All right, mode is the most frequently occurring number. So let's go ahead and write that down. So the most frequently occurring number. And of course, it occurs not once but twice. And so the mode is 24. Okay, the range is the high minus low. Okay, high minus low. Or you want to go max minus min, however you want to memorize it, it doesn't really matter. Okay, so the high value is 56. This is the high value. So 56 minus the low value of 24. and that's going to be 32. Now, if you wanted to, you could have Desmos take care of this for you, okay? All you have to do is go to Functions, go to Stats, and hit the, find the range. I think it's in here somewhere. Total length, mean, min, max, range. Well, guess what? It tells you, actually, it gives you the options of min and max. So you could use this to find the min and max, but it's too damn easy. So we won't do that. Okay. Now the population variance. So let's get the population standard deviation first. Okay. Now when you do this, you're going to go to Desmos and you're going to go to Functions again. So hit Functions and hit Stats. And then there's two deviations, okay? There's the standard deviation ending with a P. That's what you want, population standard deviation. And the other one is a sample standard deviation, okay? So you want this one. So standard, let's go get the exact symbols here. Yeah, STDEVP. So standard deviation, ST for standard, DEV for deviation, and end it with a P. You want this one. So let's go back and let's select that. Boom. Let's type in X. Well, you got to go to the next line. Sorry. Let's go back to Functions. We're going to pick the population standard deviation. Type in X1. Okay, and you get about 12.997. So this right here, population standard deviation, sigma. This is the abbreviation sigma, lowercase, is, let's look at it again. 12.997. Let's round it. So 12.997. Now to get to the variance, you just square it. So this is going to be 12.997 squared. All right, and then, oops, I didn't want to do that. Let's go back to Desmos here. I'll do everything with Desmos. And let's see. You can type it in if you want. Okay, let's just type it in. So 12.997, and let's square it. Boom. You get about 168.992. Okay, we'll keep this TID4 up here just in case we need it. I didn't really mean to do that. So 168.992. 168.992 rounded. Okay, so all you have to do is take the standard deviation, square it to get the variance, or backwards, if you get the variance, you just go ahead and square root it to get to the population standard deviation. Okay, let's move on. Okay, number 2. Now, when you're doing this right here, I wouldn't just let the video roll like some people do. If you're smart, you should be pausing, playing, and try it first, and then press play and go ahead and check your results. Okay, so if you haven't done that yet, I would suggest you do that. Okay, on the next one here, what we're going to do is we're going to calculate the cumulative frequency first, but let's read the problem. So suppose the survey is taken of the age ranges. Okay, so these are age ranges at a concert. All right, and the following frequencies follow here. So 23 people were in the age for 10 to 12, so quite a few young people there. 14 people were between 13 and 15 years old. This is in years. Let's hit this in years. 46 people were between 16 and 18, so mostly high school. Okay. And there are a few people in college. 12 people were from 19 to 21. So more people in high school went to this concert than anyone else. So what's the cumulative frequency? So here you simply add them up. So let's do that. So we're going to start off with 23. We're going to add 14. 23 and 14, 37. Going to keep on adding. 37 and 46, that's 80 and 13. That's 93. All right, and continue adding here. 93 and 12 is 105. So this represents your total number of people who went to the concert. Okay, so that's the total. What's the relative frequency? Okay, now the relative frequency is, some number out of the total. So to get the relative frequency, we take the frequency and divide it by the total, which is 105. All right, so okay, so here we're going to take 23 divided by the total 105. We're going to come up with a decimal here because it's always out of the total number of people. So 23 divided by 105. So let's use let's switch to the TID4. You can use Desmos too. No problem there. If you're going to be using Desmos here, you can use the other form of Desmos, which is the Desmos Scientific. If you want to, you can use this calculator here. No problem at all. So if you want to take your values right here, so there we go, 23 divided by 105, so 23 divided by 105, whoops, we don't want to do that, there we go. All right, it's about 0.219, okay, so 0.219, and you just keep on doing that. So 37, what's the relative frequency there? So you take it out of the total. Okay, and you get well, I don't know, what do you get? So let's use a TID3 or TID4. So let's take 37 divided by 105, and let's see what the relative frequency is. And so it's 0.352. So 0.352. Again, just divide the frequency. Oh shoot, you know what, I can't believe I'm doing this here. 23, okay, relative frequency. That was the relative cumulative frequency. I just made the most common mistake right in front of you guys here. So relative frequency depends on the frequency, not the cumulative frequency. So this number here, let me fix this. And you know what, I'm kind of glad I did that right there, because that right there is the most common mistake, because I just looked at the number to the left. The relative frequency is the frequency divided by the total. Okay, so 23 out of 105, that's correct. 14, it should be 14 over 105 or divided by 105. So let's redo this here. So that's incorrect. Kind of glad I made this mistake in front of you guys because, number one, I noticed it. I showed you how to fix it. But this is the most common mistake made because the column to the left is the cumulative frequency. Okay, I'll deal with that in a minute. Okay, so 14 here. So draw an arrow from this right here, from relative frequency to the frequency. Okay, that's what you want. So that depends on this right here. So I want to take 14 divided by 105. So 14 divided by 105. Boom. That's not right. You got to type in the right numbers. 14 divided by, it's getting late, guys. I'm sorry. Okay, it's 0.133. So 0.133. Okay. Now let's go. Now there are 46 people between the ages of 16 and 18. So there's 46 out of the total 105. That's relative frequency here. It's how many there are in that group divided by the total. Looks like about close to 50%. Let's figure that out. So 46 divided by 105. Okay, and that's about 40.438. So 0.438. Rocking and rolling. And then the other one here, 12 divided by the total. Okay, and that's going to be a little over 10%. Let's figure it out. So 12 divided by the total, 105. And that's about 0.114%. So 0.114%. Now the relative cumulative frequency, all right, this guy right here, all right, depends on this frequency, the cumulative. Okay, notice that it both say cumulative. So to figure this one out, here we go. We're going to take the cumulative frequency and divide it by the total. And so we get 0.219. There's two ways to do it here. Okay, and then you're going to take the next cumulative frequency, which is 37. So 37 out of 105. Or you simply can add these two right here. I'll check that result here in a minute. So you take 37 divided by 105. And notice it says 0.352. So 0.352. Okay, and so notice if you take 0.219, the first relative frequency, and add 0.113, you get 0.352. So you just simply add the next frequency. in the table. That's the second way you could do this. Okay, if you don't believe me, then let's try it. So 0.219, all right, plus the next frequency here, 0.133. So plus 0.133, and notice what we get. Okay, so you can add the frequencies in the third column. You can do that. You can just keep on adding right here if you want. That's another easy way to do it. Or you can just take the cumulative frequency, which is 93 in this case, divided by the total. A lot of you guys were doing this when we were talking about it because it kind of makes more sense. I don't know. It depends on you. And so 0.886, let's round up. So 0.886, or you can simply add this relative frequency here. So it says 0.438. So 0.352 plus 0.438 gives you the next one. And then if you add 0.114, if you add that, okay, we should get a total of 1. Okay, and you do. If you take 0.886 and add 0.114, you get 1. So this frequency is 1. And why is that? Well, 105 divided by 105 is 1. Okay, so this must be 1. Okay, must be equal to 1. All right, little note right there. So if you don't get 1, you know you did it incorrectly. Okay, so what's the percentile rank for the age range of 16 to 18? Okay, so that's right here, obviously. And it says it's about 0.886. So 0.886 equals 88.6%. Okay, so there's your percentile rank. So this right here is what's called the percentile rank. It's just another name. Percentile rank. It's the same as the relative cumulative frequency there. So what does that mean? It means that 88.6% of all the students are less than or equal to, at or below 16 to 18 years old in the concert. So 88.6% of the people, okay, are at or below, or you can say less than or equal to here. So at or below 16 to 18 years old in the concert, or in or at the concert. Okay, and that's what it means. That's all there is to it. Okay, moving on. So here we go. Let's take a look at number 3. Now, number 3 deals with what's called the empirical rule. Okay, so let's highlight that. You can take a look at your notes. This is section 1, I think it's 1.4. All right, so let's suppose that the average mean test score in an anatomy class was 76. Okay, and it has a standard deviation of 3. Okay, so the mean is 76. We've got a standard deviation of 3. And then over here, we know that there are 60 students in the class, and it's normally distributed. Okay, that's important to know. So use the empirical rule to answer the following questions. So one of the important things in this problem here, rather than using the z-table, is that 68% of the data lies between the standard deviation of -1 to 1. Okay, within 2 standard deviations, 95% of the data exists. Okay, and then between -3 and 3, or within 3 standard deviations, 99.7% of that data exists. Okay, so given that, we have to know that, first of all, the mean always is in the center of the data here. So this is the mean mu. So this is the mean. Okay, remember, this means the standard deviation here. Standard deviation, sigma. And the mu is always in the center of the data. Okay, now in this case, the mean is 76. So let's write that down here. And standard deviation is 3. So when we add 3 this way, okay, plus 3. Again, these are the z values here already labeled. Z equals 1, 2, and 3. So when you take 76 and add 3, you get 79, obviously. Let me fix that, 79. Plus 3 more, you get 82. Plus 3 more, you get 85. On the left side, you got to subtract 3. So go this way, you got to subtract 3. So 76 minus 3 is 73. These are the scores according to the corresponding z values. Subtract 3 again, you get 70. Subtract 3 again, you get 67. Okay, so once you label the graph there, then you have to know the percentages. So what you have to know is that because 68% of the data lives within 1 standard deviation of the mean, that means 34% to the right and 34% is to the left. And you have to know your percentages. Okay, you just flat out have to memorize them. Okay, so between 1 and 2 standard deviations is 13.5%. And on the other side is symmetrical, so 13.5%. If you don't have these memorized, you better memorize them. So make a little note here. Memorize percentages. Okay, and then between 2 and 3 standard deviations is 2.35%. Okay, so 2.35 in here, 2.35% that is, and over here is symmetrical, so 2.35%. And in this little teeny area in here, in the last part beyond 3 standard deviations, right in through there is 0.15%. Very little part of the data. Very little, 0.15%. Make sure you understand these are percentages here. Okay, so you have to know the percentages. You have to memorize these. So let's highlight that. Important part here because I'm not going to tell you. So you have to label the normal distribution. Okay, and you have to label all the percentages. Okay, so make sure that you're able to do that and study properly when I give you the normal distribution and ask you guys to use the what's called the 68, 95, 99.7 rule, or otherwise known as the empirical rule. Okay, so now let's answer some basic questions here. So here we go. So what's the percentage of data less than 79? Okay, so what's the percentage or the probability that a score is less than 79? Okay, so 79 is here. Okay, now remember, before I do this here, remember half the data to the right. Okay, 50% of the data is to the right, and then 50% is to, that was to the left, and then 50% is to the right. So there's different ways to do this. So, but if you want to figure out, what is the percentage, okay, or the probability, percentage or probability that of the data that's less than 79, you find 79, which is, at the z value of 1 or 1 standard deviation to the right. And then you take a look at the percentages. So I'm looking for this area underneath the curve in yellow here, all of this. So I can see that it's going to be 50% to the left of the mean plus 34. Okay? So I'm going to say that this is found by taking 50% plus 34%, or a total of 84% probability that a score is less than or less than 79. Okay? Okay, what is the probability that a student scored between 73 and 82? So that's between here and here. Okay, so what is that percentage? Well, between 73 and 82 lies 34% to the left of the mean, another 34% plus 13.5%. So between these two scores, 73 and 82, okay, the probability that you're between 73 and 82, which is mathematically written like this, can be found by taking 34% plus 34% plus the 13.5%. Okay, so 68 and 13.5. 78, 79. So, okay. Whoa, Jesus. I don't know what happened right there. So 68 plus 68 plus 13.5. This kind of sounds like 81.5. So 81.5% of the data lists between those two guys. So we predict that the probability that anybody scored between 73 and 82 is about 81.5%. The question is how many, what is the number of students that falls in that range if you read the problem up here, there are 60 students in the class. Okay, so I need to take, this is part B now, the second part. So 81.5, so 0.815 times 60, that gives us the number of students. So 0.815 times 60. And we get about 48.9. Now, as you guys know, you got to round that. So that's approximately equal to, you can round down, okay? So you can say 48, or you can round this up and say 49 students. Probability, okay? So about 49 students. And again, this is approximate. Okay, between 48 and 49 students approximately. Okay, what is the percentage of people who scored at least 70? So we want to find the probability that the score is less than or equal to 70. What would that be? All right, so that is to the right of 70. So percentage-wise, and we're going to take a look at right here, what's the percentage of people to the right of 70, all in this blue region right here. So to the right of the mean is 50%. And then we got to take into account 34% and plus 13.5%. Or you can say 47.5. But let's just add it up individually so see if it makes sense for you. So from left to right, so 13.5% plus 34% plus the right side, which is 50%. That's 84 and 35. Okay, so in this case, it's the same value as before. So 81.5%. So it's kind of, that there is just a coincidence, by the way. Okay. What's the how many students scored more than 82? So how many students? We need the percentage first. Okay, so more than 82 is we got to get the percentage. Which I see to the right of 82 is 2.35 plus the 0.15. So the probability that we're greater than 82 is 2.35% plus 0.15%, which is just 2.5%. To calculate the number of people, how many people, you got to take 2.5% out of the total, which is 60, which is 0.025 times 60, and then round your answer. So 0.025 times 60, we get about 1.5. So 1.5 students. So you can round down. So if you round down, it's 1. If you round up, it's 2. So between 1 and 2 students. Okay. But if you round down, because again, this is an estimation, so approximately 1 student if rounded down. If you round up, it's approximately 2. So it's basically between 1 and 2 students. So let me just make note of that. Between, 1 and 2 students approximately. Because again, this is only an approximation. This is not an exact science at all. Okay? Okay. Let me see. That's the empirical rule. Let's talk about the normal, let's talk about how to use the z-table. Okay. Let's review this here. So using the z-table now, not the empirical rule. So we want to show how we're calculating. So here we go. Suppose we have a normal distribution where the mean is 42 and the standard deviation is 4. Okay, so let's detail that out. So these are the z values here that's in the graph. Okay, so let's say we have a mean mu of 42 that corresponds to the standard normal of 0. And then we have a standard deviation of 4. So let's say if we add 4 here, okay, we're going to get the scores of 46, 50, and 54. If we subtract 4 going to the left, so that's a minus 4, we have 38, minus 4 is 34, minus 4 is 30. So these represent your scores. Okay, remember the mean is directly in the middle, so let's highlight that. So the mean's always in the middle, and the mean is 42 in this case. All right, let's find the following probabilities, but this time we're going to be using the z-table, so get ready. Okay, if you don't have your z-table out, pause the video and get that ready. I'm going to be using mine. So what's the probability that the score is less than 37? So 37 is between 34 and 38. So the z-value, according to that, is between -1 and -2. So this is a negative z-value. So let's find it first. Let's find z. Okay, so z it's right up here. This is the typical formula up here. Is always found by taking the score minus the mean divided by the standard deviation. So this is the score, this is the mean, and this is the standard deviation. That's how you find the z-value every single time. Now the score right here is 37. So what we're going to do is we're going to take 37 minus the mean, which in the problem is 42. Just look at the graph. Divide that by the standard deviation of 4. So let's get a z-value. So it better be between -1 and -2. So 37 minus 42 is -5. -5 divided by 4 is -1.25 or -1.25. There's my z-value. If you don't believe me, just figure it out. So you take -5 divided by 4, and it should be the same. Okay? Now, we need the probability. So this is equivalent to finding the probability that z is less than -1.25 on the z-table. So what is that probability? So let's look at the z-table here. So let's map it out. So here I got to take -1.2. Come on. There you go. 0.05 up top. Okay. -1.2 plus 0.05 is the same decimal as -1.25. Okay. Using the z-table, you look across and down and figure out that value. You know, what is this probability in the z-table? So let's go to the negative side of the z-table. Let's find -1.25. So let's highlight it here. So -1.2 is here. And then we got to find 0.05. And I see a probability of 0.1057. 0.1057. So 0.1057. That equates to 10.57%. That's the probability that we have a z-value that's less than -1.25 or a score that's less than 37. And I predicted, 37's right around here somewhere. Okay, so it has to be between -1 and 2. And I got a z-value that's -1.25, so that makes sense. And then the area left of that, it's pretty small. Okay, it's this area here. Okay, all through here. And it says in the table that it's 10.57% probability. All right, so 10.57% probability that a score is less than 37. Okay, next one. What's the probability that we have at least 47? So this right here is equivalent to 1 minus the probability that the score is less than 47. So we got to figure that out first. And we need a z-value for that. So the very first thing I do is I find the z-value. So 47 minus the mean of 42. Now 47, by the way, is over here to the right somewhere. So it's right around in here. I don't know. 47 is over here. So the z-value is between 1 and 2, whatever it is. So 47 minus 42 divided by 4. So that's going to be 5 fourths. 1.25 again. So this is positive. So when we use a table, now we have to look at 1.2 here, all right, and 0.05 up here. So let's figure out what the positive value is. Okay. Probably guess what it is because it's symmetric, but let's go ahead and just prove to ourselves, what it is. Let's go to the positive side. And let's figure it out. So looking at here, we got 1.2, and then let's go across. Go down, here is 0.05. So it's 0.89435. So 0.8944. Okay, so 0.8944. So 0.8944. Okay, so this is 1 minus 0.8944. Remember, these probabilities are to the left. So this is left of that value. But I want to the right of that value, so I got to subtract it from that. So 1 minus that. So let's go 1 minus 0.8944 and get 0.1056. So 0.1056, which corresponds to 10.56%. And notice that I thought, it's symmetrical here, guys. So this area here to the right, let me put it in red. Should be symmetrical with the other one. Okay, and notice that the answers are pretty much the same. I'm only off by 1/100th here. Okay, there's a little rounding error here. All right, so there we go. So when you approach the less than case, it's different than the at least case because this is to the right and the previous one was to the left. So we had to subtract it from 1 or 100% to get the area on the right. Remember, the area underneath the curve is 100%, so keep that in mind. Okay, and now when we figure out the area between two values, between 38 and 48, which is, you can kind of see it on the graph right there. So 38 is here. Let me see, let's switch different colors. Let's go to purple. So 38's here. 48 roughly here. So we're trying to find the area in this purple region. So this is purple here. So what we're going to do is we're going to find this is equivalent to the probability that you're less than 48 minus the probability that the score is less than 38. So I need some z-values. So let's get some z-values first. Let's do our homework. So let's start off with 48. So 48 minus the mean. Now remember the mean's 42 up there on the graph. It's the value in the middle. Remember, it's a middle number there. So 48 minus 44 divided by 4. Well, guess what? It's 1, and it better be. Look at the graph. 38 has, excuse me, I didn't say that right. So let's go back here. No, I said that. Yeah. What'd I do? What'd I do wrong here? Oh, I didn't put the right number in. The mean is 42. I knew I made a mistake. I just couldn't figure out. I wrote down 44. I meant 42. So the mean. So it's always x minus mu, which is 42, divided by 4, which is the standard deviation. That gives us 6 divided by 4, or 1.5. That makes more sense. Because look at right here. 48 is between 46 and 50, which is halfway between 1 and 2. So it should be 1.5. Okay. So the other z-value, let's take the other value, 38. So here we go. So it helps when you guys, to make sense of your numbers here. So the score minus the mean divided by the standard deviation. This will give you -4 divided by 4, or -1, which makes sense. Because if you look at the graph, 38 is 1 standard deviation away from the mean to the left. So it has to be having a z-value of -1. I didn't even have to calculate it, I knew it. Okay, now let's get some z-values. So let's draw the graph here. So for 1.5, it's 1.0 and then 0.5 up top. Okay, so let's get a z-value here. So we look at 1, and then we go to 0.5. No, excuse me, 1.5. So scratch what I just said there, 1.5. So let me fix my little z table here. Let me go back to the lesson. I didn't mean to say that. So not 1.0, 1.5, and then 0. So you put 1.5 here, and then 0.0 here. 0.00, let's say. And then what's the Z value? So let's go to the positive value. So 1.5 and then 0. So you look here, 0.9332. All right. So 0.9332, 0.9332. There we go. That's 93.32% if you want to use it as a percentage. All right, and the next Z value, here we go. It's -1. So -1 here and then 0 here. -1.0 is the same as -1, right? So you just look at the Z table, find -1. So let's go to the negative side. Okay, -1 is here. Let's go to a different color. -1 and then 0. So I see 0.1587. 0.1587. Okay. 0.1587. And if you want to, as a percentage, that's 15.87%. So if you want to use percentages, you can use them, or you can use the decimals. It doesn't matter. They're just probabilities here. Okay, so let's put the probabilities in. So 93.32% minus the small one, 15.87%. What does that equal? So let's calculate it. So here we go. Press clear. All right, so 93.32 minus 15.87. All right, and 77.45. So 77.45% would be your answer there. Okay. Whew. Okay, I'm getting tired. All right, it's almost midnight. Okay, so here we go. So what else do we have to do? Okay, ooh, scatter plot, do a little linear regression. Okay, so here we go. I found this cool problem for you guys. So Earth's population continues to grow, or as it continues to grow, the solid waste generated by the population goes with it. That should make sense, right? Governments must plan for disposal and recycling for ever-growing amounts of solid waste. Planners can use the data from the past to predict the future. That's what we want to do, of waste production, and plan for future facilities for disposing and recycling the waste. So given the data here from years 1990 to 1994 in Florida, okay, this is actual data, how can we construct a function to predict the waste generated in the years of 1995 to 1999, or maybe even 2000. We'll go to 2000. Okie dokie. So here we go. So we're going to need to enter the data, and we're going to be using Desmos. Okay, so we're going to use Desmos here. Let's go to the data, to Desmos graphing calculator, and let's clear this out because we used this before. So let's start over. Here we go. Okay, so let me enlarge the screen a little bit here. So let's enter the data. So let's go to the plus sign. And, oh, by the way, before we do this here, there's two different ways to do this here. But what I'm going to do, oh yeah, let's read the problem here. So it says make a scatter plot of the data, letting X represent the number of years since 1990. Okay, so what that means is this. So I'm going to let X represent the number of years past 1990. So that's our starting point. So X equals 0 here. It corresponds to 1990. X equals 1 corresponds to 1991. X equals 2 corresponds to 1992, and so on. You see the pattern here. And so you can say hi to my son right here. Here he is. He's going to help me do this right here. And X equals 4 represents 1994, and so on. And then if you just take a look at the pattern, X equals 5 represents 1995. It's pretty self-explanatory. X equals 7, 1997, and then X equals 8, X equals 9, and X equals 10 represents the year 2000, which means that it's 10 years past 1990, which should make sense. Okay, so we're not going to enter a 4-digit year. We're going to enter these values here for the year, and then we're going to enter in these 5-digit numbers for the total, the tons of solid waste generated in thousands. Whew. Okay, and then we're going to predict that for 1995, because I don't have 1995 data, nor do I have any data up until year 2000. Okay, so let's see if we can continue here. All right, so let's enter in the data. Let's put it side by side with Desmos here. If I can get that going. Okay, so here we go. Let's enter in. Let's add a table in here. So select table and go for it. So 0, 1, and then all the way. Go ahead and enter all the way up to 10. Actually, we're only going to go up to 5. So let me go back here. Okay. So let's enter in the data points. Let's put in the tonnage. It's a cool word, tonnage. Okay, so what's the tonnage? So let's put this in the next column here. So 19,358,000 metric tons. So, and then let's go to the next one here, 19,000. All right, 484. And this is in thousands of tons. So you have to multiply each one of these numbers by 1,000. So 20,293. Just go ahead and enter these guys in so we can do some linear regression here and figure out how to predict the future. Oops, I missed a number here. What happened here? 19. Oh, we gotta go up to x equals 4. Yeah, I entered too many values there. So delete 5. Okay. And then the last value is 23,561. Okay, so once you have your data in, okay, so what you want to do here is calculate the linear regression line first. So go down to line 2, as I said in the previous lesson here. Okay, you're going to enter in y1. Okay, y1. You just type in y1, okay? Not equals, but tilde. Now, tilde is near the number 1 key in the upper left of the keyboard. Very, very important. Now, that's kind of like an approximation symbol because the linear regression line is not an exact prediction tool. It's an approximation tool. So we don't use the equal sign. We use a tilde right there. So find it on your keyboard. That little squiggly is called the tilde. All right, and type in M and then X1 and then plus B because this is a linear regression line and every linear function is in slope-intercept form on right here, or it can be expressed in intercept form. Which is typically, if you remember correctly from Algebra 1 days, many years ago, it's y equals mx plus b. So here it calculates that we have a slope of 1,042, and then we have a y-intercept of 18,754. Notice that we don't see the points. So let me enlarge this so you can see a little bit better here. We don't see any points. And the reason why we don't see any points is because, okay, we haven't set the scale. So go to the upper right. Actually, before we do this, let me just double check something here. So we have 1, 2, 3, 4, 5 data points, 0. I'm just checking the data points to make sure I type these in correctly. Yeah, it looks good. Okay, so let's go to the wrench, okay, which is the graph settings. Notice the x values are between 0 and 4, so change it from 0 to 4. Actually, let's go a little bit higher because we want to predict all the way up to 10 years past 1990, all the way up to year 2000. So type in 10. So 0 to 10, not 4 to 10, 0 to 10. So change your x-axis. I'm scaling the graph here and make the step equal to 1. And notice that the x-axis just changed. It went from 0 to 10. So basically what I'm doing on the computer is I'm scaling the graph, the axes, just like I normally would. Now the y-axis, if you look at the table here, none of the values are below 19,358. So I'm going to type in 19,000. And then on the maximum here, let's go up to 25,000. And let's step it out by 100. So let's put 100 in for the step. That should be good. And we should be able to see the points. Okay, so notice that we can see the points now, and we also see the regression line. This is called a line of best fit or a regression line, and it fits the data here. Notice that the correlation coefficient is 0.9445, which means that the correlation between the data, between the years and the tonnage, is a strong correlation, which means as over time, as years increase, the amount of tons increases, and you can see that through the data. That's what a strong positive correlation means. Let's write out the linear regression function. So y equals m Look at the above here. It's m is equal to 1042.1. So just type that in. All right, times x. Got to put the x in there. It's in slope-intercept form, guys. This is a linear function. All right, plus the y-intercept. That's your b value, and b right above it is 18,754.8. All right, and there's your linear regression equation, or what's known as the line of best fit. Okay. Next thing we need to do is predict what is it, in 2006 and so on. So let's just type again y equals mx plus b. Pretty simple. Okay, and then you're going to go up to the gear or the cog up here in the top where it says edit list. You're going to click on that, go back down to your function, and you're going to see a table icon, and hover above it, and you're going to see convert to a table. We'll click on that, and Desmos automatically defaults starting at -2, but you want to change that. Now the next value in the table is it's going to be 5, right? After 4 comes 5, so type in 5. Okay, that represents 1995. Let's go back to the table. Let me just show you what. Let's go review here. In here. So x equals 5 corresponds to 1995. So when you want to enter in 5, right? So we enter in 5, and we expect that the tonnage would be 23,965,000 tons. Okay, it's huge. You type in 6 to get 2006, type in 7 to get 2007, 8 to get 2008, and then 9 to get 2009, and so on. One more time, and you can get all the way to then the next year, which would be 2000. Okay, so we can take these values. Let's go ahead and clip this in here. In fact, we can screenshot this whole thing, which is kind of nice. This is what we did in class. So I'm going to screenshot this. I'm going to get the values here, the predictions first. I'm going to go back to our lesson here. Paste that in. So those are my predictions using Desmos. Okay, I'm just going to make those. There we go. There we go. All right. And then, let's just bring them over. No, I don't want to do that. Okay, and then let me see. What does the graph look like? And then what is the line of best fit? Okay, so let me grab the line of best fit here. Let's go back to Desmos. So let me screenshot that. So this is what the scatter plot looks like here when you plot it. Okay, and let's get the linear regression line. This is the line of best fit. Our prediction tools is the last thing I need, so let's go back to Desmos. It's right here, so just highlight your regression equation, copy it. Actually, you know what? I'm just going to screenshot the entire thing because I want to see it. So I'm going to get the regression equation plus the correlation coefficient. So notice here. So this right here that I copied is the line of best fit, or the regression equation. So linear regression equation, or commonly known as the line of best fit. Line of best fit. Okay. And then the correlation coefficient, R. Okay, this is called the correlation coefficient. Okay, that tells me, okay, so since R equals 9445, it's close to 1. Close to 1. Let me write that a little bit better here. Because it's close to 1, all right, this represents a strong positive correlation. Strong positive correlation. What does that mean? It means that, you guys, is very, very simple. As the years increase, okay, the tons of solid waste increases. They both increase together. Okay, so over time, the tonnage of waste increases. That's what it means. So whenever you have a strong positive correlation, it means that as one increases, the other one increases. And that should make sense because there's something called, well, the populations increase, the amount of waste increases as the population increases. Just kind of common sense. Okay, now remember, these are the predictions. You guys can write them down. I'm just copying them from Desmos. You guys can obviously write those down. All right, so using Desmos here, we're able to see the graph, see the scatter plot, get the correlation coefficient, come up with the predictions using the regression equation, and making a table of values. And that is exactly what you guys need to be able to do. All right. So I pretty much covered everything that we've studied over, maybe not everything, but a lot of what we studied in the chapter 1. Okay, like in any video though, you have to make sure you understand it. And if you don't, then you have the opportunity to go back and review whatever you're weak at. So be smart, be wise, go back and practice and focus in on your weak points. Okay, and remember, you're expected to do all of this on your own on test day using something like Desmos, okay, or the T84. All right, that's it for me. It's past midnight, guys, so I'm going to go to bed. Talk to you later. Good luck in your studying. Talk to you soon. See you in my next lesson. Bye-bye.